The E2 reaction is another reaction from the big four. The E2 reaction requires a reactive anion. Now we just finished talking about another reaction, the SN2 reaction, which also needs a reactive anion, but this was a nucleophile. And of course, it's not just any nucleophile, but a strong nucleophile. We put our strong nucleophiles into categories. We have the really great ones and then the good ones, but we need a nucleophile. And the nucleophile is almost always an anion. Okay, it's got a negative charge. What's a nucleophile do? It attacks a carbon. An electrophilic carbon, it's the carbon that bears a leaving group. The E2 is similar, except for the reactive anion in the E2 doesn't act as a nucleophile. It instead reacts as a base. And since it is a reactive anion, it is strong in reactivity. It's not strong as a nucleophile, but it's strong as a base. What do bases do by definition? Well, bases remove a proton. They're going to find a hydrogen atom and remove that hydrogen atom. So this kind of gets you into the distinction between the E2 and the SN2. However, there's a lot of overlap. Your strong base will also often be an anion. So we're going to look for reactive anions. So one challenge we'll have is we'll find reactions that contain strong anions, and we'll have to decide, is this going to behave as a nucleophile or as a base? So what are the most common bases? We've already seen the common nucleophiles, but the common bases are bases that you already know. Sodium hydroxide. Hey, there's a reason why you learn that sodium hydroxide is a base. It is a base. And when people talk about doing an E2 reaction, sodium hydroxide is a base that they'll use. Sodium hydroxide has close family members, the alkoxides. And at their heart, alkoxides are really bases for the same reason that hydroxide is a base. Hydroxide has this localized O-. Alkoxides have a localized O-. So they're very similar in terms of bases. Rarely, your base might be something like an amine. One of the classics is triethylamine. So let's write that out in a full structure. Now, amines don't have the striking anionic properties that you see in the alkoxides. Alkoxides are both anions. Amines have this neutral nitrogen lone pair, but actually that's pretty basic, and it can remove a proton just like hydroxide can. Less common, but you will encounter them. So what does our base react with? Our base reacts with as with almost all the big four reactions, it reacts with an alkyl halide. So when the base reacts with an alkyl halide, the base is going to remove a proton. So we're not reacting directly with the halogen in the halide. We're going to remove a proton, and this somehow is going to form an alkene. And any reaction that forms an alkene, by definition, is an elimination. So we'll see a specific example of this and see how all this comes together, how the base removes a hydrogen, and that causes loss of the halide and formation of a new carbon-carbon double bond, or an alkene.